John Berg. I'm with Century AC Supply, and I do the training here. What we're going to do is have a segment today, and we're going to talk about superheat and subcooling. Why is it necessary? How do you do it? What does it tell us? And let's talk about air conditioning for a moment. Air conditioning has everything to do with temperature. And that's why, even though we use gauges, the gauges that we use are only there to tell us temperatures and compare them with other temperature readings that we're taking. The importance is today's equipment requires superheat and subcooling. We don't go by beer can cold anymore. We don't go by 70 psig. We don't go with 225. All of those are pressure numbers, have nothing to do with temperature. Temperature is everything in air conditioning. The tools necessary to take proper superheat and subcooling measurements are a set of gauges, a temperature sensor, preferably a clamp-on. Please, I discourage use of the lasers. Lasers are a very good tool for getting approximate temperatures. They are not a good tool for getting accurate readings. And we're after accurate readings. To go along with that, of course, is our safety precautions we need to take, our goggles and our gloves. Whenever we're handling refrigerant, there is the possibility that liquid can come out of our hoses. It can get on our fingers. It can get in our eyes. And in either case, it's boiling at -50 degrees. It will cause frostbite. It could cause severe eye damage. Subcooling is taken on the liquid line, leaving the condenser. What we want to do is, in the superheat and subcooling, in air conditioning, what is required that at the metering device of the evaporator inside the cabinet of the unit, we have to have liquid entering the metering device in order to get evaporation through our evaporator. The only way to do that is to determine that we do have subcooling, that we do have a liquid. When we take our temperature pressure readings and we look across at the temperature pressure, we see that there's a saturation temperature, and that is the temperature at which inside the condenser coil, the hot gas coming from the compressor going into the condenser is being cooled by the outside ambient air. Once it is cooled below its saturation temperature, then we have liquid. And in order to have liquid, in order to know we have liquid, we have to take a pressure reading, convert it to its saturation temperature reading on the green dial, and then compare the discharge liquid line temperature to the saturation temperature of the corresponding pressure. Subcooling is the amount of temperature removed below the saturation temperature of our refrigerant to ensure that we have liquid going to the metering device. Again, pressure will not tell us that by itself. Temperature will not tell us that. We're going to let this thing sit here and let it stabilize out, and the reading I get, 73.57, 73.78, is fluctuating up and down. The temperature reading there, 73, doesn't tell me anything. Also, when I look at my pressure gauge with the unit running, I'm reading 148 psig, and that doesn't tell me anything. But taking the two together, now I begin and start seeing a picture of exactly what's inside that refrigerant line. And the 148 psig is equal to, using my temperature pressure chart, 148 psig is equal to 82 degrees saturation temperature. My actual reading is 74, which means I'm 8 degrees below the saturation temperature, which means it has to be a liquid. The laws of physics, this is where they come into play. These are some of the very basic components that we deal with, that we need to know the basics of in order to understand what the gauges are telling us. The gauges are there only to convert to a temperature. Only to convert, because if I looked at those gauges and as they are saw 74-pound suction and 150-pound head pressure, my first indication would be those valves are not working correctly. Yet, when I take my corresponding temperature, convert to pressure to saturation temperature, both the superheat and subcooling, and then take actual temperature readings, now I get a picture of what is going on inside that condensing unit. Remember, coming back to the compressor, we have always got to have vapor. Going to the metering device, we have always got to have liquid. That's the reason for taking pressure readings and converting it to a temperature. The temperature readings we're taking are going to be converted from the pressure readings on our suction pressure gauge. And we convert that by using either our gauges, which once we read the pressure reading, we come down to the green numbers inside, and that will convert to a temperature reading, or we can use this temperature pressure chart, which gives us a far more accurate reading. Next, we let it run, and then we clamp on our temperature clamp onto the suction line and have it set on the temperature indication, which is 57.8. And we correlate that with our, what is that, 73-pound suction pressure, which 73 gives us a 44. And let me look at this thing to make sure. 73. We look at our temperature chart for R22, 73 psig correlates to a 43-degree temperature reading, saturation temperature. The 43 from 57 puts us at 14 degrees of superheat.